Assalamu alaikum. Today in this video we are performing lab number 8 of a linear circuit analysis. Title of lab number 8 is to understand the basic series parallel DC circuit with resistors. Means that in this lab we have to perform a combination of series and parallel DC circuits with resistors. We will analyze the series section and the parallel section of the combined series parallel DC circuit. To perform this lab, we are in need of a DC power supply, digital multimeters. Instead of digital multimeters, we can also use the ammeter or voltmeter. Similarly, we will in need of a different value resistances. In our case, we are considering a 220 ohm, 330 ohm and 1 kilo ohm resistors. Means that 3 different value resistances. We will need a breadboard for inserting our components and obviously connecting wires to interconnect these components as well as with the power supply. Identification of series parallel circuits. First of all, we are in need that how a series parallel circuit can be identified. So as we know that series parallel circuit is a combination of both series circuit and parallel circuit. In other words, we can say that series parallel circuit is a combination of both series and parallel current paths. Important is how to identify that these components in a circuit are arranged whether in a series relationship or in a parallel relationship. Now each sub-circuit, which might be series circuit or parallel circuit, may be analyzed through basic series and parallel techniques which we have already discussed in previous labs. For example, for the series circuit, we can apply the voltage divider rule and the Kirchhoff voltage law. You can see that voltage divider rule where Vx is equal to Rx divided by R total into Vs, as we have seen in lab number 4 and 5. Similarly, for the parallel circuit, we can use the current divider rule along with Kirchhoff current law. The formula for finding the current across any branch is such that Ix is equal to R total divided by Rx, means resistance in that branch, multiplied by I total, as we have seen it in lab number 6 and 7. The schematic diagram through which we will perform our experiment is such that it consists of 3 different resistances, labeling R1, R2 and R3, and a power supply. Here you can see that R1 is in series with a pair of resistances R2 and R3 which are in parallel. Value of these resistances are such that R1 is equal to 220 ohms, R2 is equal to 330 ohms, while R3 is equal to 1 kilo ohm. We have used a DC power supply with the name of E, which we also represent by Vs, mean supply voltage, and that is equal to 5 volt. First of all, to find the total current, we have to divide the total supplied voltage over the total resistance. The total resistance can be found such that R1 is in series with R2 and R3 which are in parallel. In other words, we can say that R1 plus R2 and R3 are in parallel, so their equivalent resistance will be equal to R2 into R3 divided by sum of R2 plus R3. In this way, we will find the equivalent resistance of a R2 and 3, and these resistances will be added with the resistance of a R1 to find the total resistance. The procedure for performing this experiment is such that first of all we have to find the theoretical results or values. So as per given circuit diagram, we have seen that R2 is in parallel with R3, and this combination means that combination of R2 and R3 is in series with R1. So thus, we can say that R2-R3 pair may be treated as a single resistance to form a series loop with R1. Now, we have to determine the theoretical voltages at point A with respect to ground, point B with respect to ground, and point C with respect to ground. And we will note out these values in table number 1. After calculating the theoretical values, now we will come towards the experimental results. To calculate the experimental values or results, we have to construct our circuit diagram as per given schematic diagram. After that, we will set the DMM to measure the DC voltage. Then, after setting the DMM for measuring the DC voltage, we will apply it to the circuit from point A with respect to ground, or from point A to the ground, and we will note out this value in table number 1. Similarly, we will repeat the same process for measuring the voltages at point B and point C. We will put these values in table number 1. After putting these values, we will also determine the deviation. Deviation means the difference between the theoretical and the experimental values. As you can see that table number 1 is representing the voltage measurement. Here you can see that we will find 3 types of voltages at 3 different points, at point A, point B, and point C. First of all, we will calculate the theoretical values. After calculating the theoretical values, we will measure the voltages at these 3 points using the DMM, and after measuring the voltages, now we will calculate the deviation between the theoretical and measured values. Similarly, to find the current, first of all we have to determine the theoretical results. So we will apply the KCL to the parallel subcircuit, means the subcircuit which consists of a R2 and R3 resistance. So current entering node B, that is current through R1, means that I1 coming from the power supply and flowing through the R1 will be distributed at point B. This current will be equal to the sum of the currents flowing through R2 and R3. Mathematically, we can say that I1 current flowing through R1 will be equal to the sum of the currents flowing through R2 and R3. Means that at point B, our incoming current, which is I1, is divided into 2 different currents, I2 and I3. These currents can be determined through Ohm's law or again the current divider rule. After measuring these values, we will write down these values in table number 2. To calculate the experimental values or results of currents, we will set the DMM to measure the DC currents. After setting the DMM, now we will measure these 3 currents I1, I2 and I3 by inserting the DMM in series with R1, then R2, and then in series with R3. We will write down these values in table number 2, and after that we will calculate the deviation. Here you can see that table number 2 is representing the current measurements in the given circuit. So you can see that first of all we have to determine the current through R1, through R2 and flowing through R3. Then after calculating the theoretical values of all these 3 currents, we will measure the experimental currents using the DMM, and finally we will find the deviation between the theoretical and measured currents. Demonstration of the experiment. As you can see that we have considered a circuit with three resistances, where R1 is in series with a combination of two resistances R2 and R3 which are in parallel. Means that the combination of R2 and R3 which are in parallel is in series with the R1 resistor, while the R1 resistor is connected with the positive terminal of a power supply and the negative terminal of power supply is connected with the parallel combination of a R2 and R3 resistances. So first of all, we have to implement our circuit such that you can see over here we have three resistances, R1 which has a value of a 220 ohm, R2 with the 330 ohm resistances, while R3 with 1 kilo ohm resistance. You can see that R2 and R3 are in parallel and both these resistances are connected in series with the R1. Now we have to supply the voltage. We will use the DC power supply of a digital channel. Here we can see that how many voltage we have to provide to the circuit. So first of all, we will select the DC voltage from the meter. Here is a range of 10 volts, means that this meter will show us up to 10 volt of a DC voltage. We found that this is approximately equal to 5 volt, 5.03 volt. Now we have to connect this power supply to the circuit. So first of all, take the positive terminal of the battery and connect it with the R1 resistor R1. Similarly, take the ground terminal of the battery and connect it with the parallel combination of R2 and R3. In this way we have connected our circuit. Now according to the circuit, the meeting point of the R1 and the power supply is point A, while the connected node of R1 and R2 is a point B, and the point between R2 and R3 is considered as a point C. We have to measure the voltage at three different points: point A, point B and point C, and after measuring the value we have to put it into the table number 1, where we are considering voltage A, voltage B and voltage C. To check the voltage across point A and ground, we will connect our voltmeter with the positive terminal of the supply or the resistor R1 and the negative of the power supply. So we are getting here 5.018 volt. Now we will find the voltage at point B. So at point B we have to connect the positive terminal with the junction or the meeting point of R1 and R2, and the negative terminal with the ground or the negative terminal of the power supply. So you can see that we are getting 2.65 volt over here at point B. Similarly, at point C we will determine the voltage at point C such that we will connect the positive terminal of the meter with the R3 and the negative terminal with the ground, and you can see that again we are having 2.656 which is approximately equal to 2.65 volt. So in this way we have determined the voltage across three different points. Similarly, we can determine the voltage across R1, which must be equal to the difference of supplied voltage and the voltage drop across R2 or R3. You can see that this is approximately 2.348. Voltage from point A to B is equal to 2.348 volt. Now we have to determine the three different currents flowing through R1, R2 and R3 in our circuit. So to find the current, we have to adjust our multimeter over the range of a DC current like this one. So you are having over a symbol of ampere. Similarly, we can decrease the range up to 100 milliampere. Now this meter will show us a 100 milliampere current. To find the current at point A or current flowing through R1, we have to disconnect the one terminal of the resistances like this one, and now we will find the current through RA is approximately equal to 107 milliampere. In similar fashion, we will find the current through flowing through R2 and R3, which we have already noted over here, and we will show you on the paper. Thank you very much.